Greetings, Calc 2 students. This video is for section 7.7, Simpsons Rule. So Simpsons Rule was developed by an English mathematician by the name of Thomas Simpson. And that mathematician discovered that you could approximate the area underneath the curve by utilizing parabolas instead of straight lines. So the midpoint rule that we've talked about and the trapezoid rule that we talk about uses straight lines. The midpoint rule uses rectangles, and the trapezoid rule uses trapezoids. Well, Simpson's rule uses parabolas. So let's take a look at the algebraic definition of Simpson's rule. So S sub n is equal to delta x divided by 3. Then we take delta x divided by 3 and we multiply it by the endpoints, x sub naught and x sub n. We put those individually into the function and add those together. Then we do this pattern of 4, 2, 4, 2, 4, 2 for all of the rest, the things in the middle, that we evaluate. So x1 into the function multiplied by 4, x2 into the function multiplied by 2, x3 into the function multiplied by 4, and so on and so forth until we're at the end. So once again, our endpoints are put into the function. And then the middle points are multiplied by 4, 2, 4, 2, 4, 2 after we apply them into the function. Where n is restricted to be even. So the Simpson rule has to have an even number of subintervals, and delta x is b minus a divided by n. Okay, so let's do that same problem that we've been working on before, where we're evaluating the integral from 1 to 4 of x squared dx, and we have found that that's equal to 21. And let's approximate that with the Simpsons rule with 6 subintervals. We want to approximate with 6 subintervals. So what I'm going to do then is s sub n. So this will be a 6. I can actually change that to a 6. S sub 6 is going to be delta x divided by 3 times the quantity. I put the endpoints into my function and evaluate those. And then my first point into the function times 4, x sub 2 into the function times 2, x sub 3 into the function times 4, x sub 4 into the function times 2, x sub 5 into the function times 4, and then we'll be finished. So the first thing I found then, after I wrote out what it would be in this particular case, is delta x. So b minus a divided by n is 4 minus 1 divided by 6, or 3 over 6, which is the same as a half. So then how do I find my my points? Well, x naught is the first one. And then x1, my first point is, well, I just move over by delta x. I move over by a half, so that's 1.5. Then delta x2 is 1.5 plus delta x, so that's x2. So that is 1.5 plus 0.5 is a half. And then x sub 3 will be 2 plus delta x, 2.5. x4 would be 2.5 plus delta x, so 3. And x5 would be x4 plus delta x, so x5. And then the last one would be x6 would be x5 plus delta x, so 3.5 plus 4. And notice, for this case, in the Simpsons rule, we start with 1 and we end at the endpoint, which is 4. Okay, so let's plug in all those values. So 1/2 is my delta x. I divide it by 3 from the formula, and then I multiply by the first initial value put into the function is squared, so 1 squared. Then I did the last one, so 4 squared, and then I do all the ones in the middle. So 0.5 squared times 4, then 2 squared times 2, and then 2.5 squared times 4, and then 3 squared times 2, and then 3.5 squared times 4. And I already did the 4 square on the end. And I sum all of those things up. So 1 squared plus 1.5 squared times 4, and 8 is the same as 2 squared times 2, and 2.5 squared times 4 is 25, and so on. I sum all those up, and I get 1/6 times 126, which equals 21. So it's easy to see that the trapezoid rule was actually a great approximation with the subinterval S sub 6 was a great approximation because in this case it was actually equal. So the trapezoid is a very powerful technique and it gives you a great approximation.